Now we will discuss limits of multivariable functions. So for that we need to know the limit for one variable function. That is, we first discuss limit for this function y equal to fx. So here limit x tends to a, f of x equal to L when fx approaches to L as x approaches to a. Then we said that the limit of this function equal to L as x tends to a. So mathematically we will define the limit of a function, that is delta epsilon definition. For epsilon greater than 0, there exists a corresponding delta greater than 0 corresponding real number delta greater than 0 such that modulus mod of f of x minus L less than epsilon whenever 0 less than x minus a less than delta. So this is the definition of limit of a function. This is delta epsilon definition. So if for every epsilon greater than 0 there exists a corresponding real number delta greater than 0 such that this inequality happens whenever this inequality satisfied, then we said limit of this function fx equal to L as x tends to a. So let us take one example. So limit x tends to 2, 2x plus 1 equal to 4, sorry 5. So we will prove this by delta epsilon definition. So first we take, let epsilon greater than 0 be given, then we find fx minus L, that is here fx equal to 2x plus 1 and L equal to minus 5, and then this becomes 2x minus 4 and this becomes 2 into x minus 2, and this becomes less or equal to 2 into modulus x minus 2. So we have to prove that this equal less than epsilon whenever 0 less than x minus a, that is here a equal to 2 less than delta. So whenever this, so we put this inequality, that is modulus x minus 2 less than delta, and we get from here this less or equal to 2 delta. So from this we can see if we choose delta less or equal to epsilon by 2, then this from this 2x plus 1 minus 5 less than epsilon, that is 2 into epsilon by 2, that becomes epsilon. So we get that for epsilon greater than 0, if we choose epsilon greater than 0, then we can find delta which is less or equal to epsilon divided by 2 such that this happened, 2x plus 1 minus 5 less than epsilon. So from this we can say that limit of this function equal to 5 as x tends to 2. Now we discuss limit of function of two variables. Function of two variables means that is z equal to f of x comma y. Limit x comma y tends to x0 comma y0 f of x comma y equal to L. So when we said the limit of this function as xy goes to this equal to L, we say that the function, this is short form of function, that the function f of xy approaches to the limit L if the value of f of xy lie arbitrarily close to L for all x comma y which are sufficiently close to x0 y0. So this is the meaning of this limit of function of two variables. So we say that the function f of xy approaches to the limit L if the value of this function lie arbitrarily close to L for all xy which are sufficiently, or this point x comma y that sufficiently close to the x0 y0. Now we discuss the mathematically. Mathematically, same as before, for epsilon greater than 0, there exists a corresponding real number delta greater than 0 such that mod of f of x comma y minus l less than epsilon whenever 0 less than root over x minus x0 whole square plus y minus y0 whole square less than delta. So graphically, this means that this point x0 y0, and this means a disk, circular disk, that is deleted neighborhood except this point. So for all those points, this inequality hold. And if we take this as rectangular, so then we get this condition as 0 less than x minus x0 less than epsilon and 0 less than y minus y0 less than delta. So we can use this or this for our example, or to prove the limit of a function, we can take any of them. So we can take the circular disk and rectangular. So now we take some examples. Let us take a simple example. X comma y tends to 1 comma 2, 2x plus y equal to 4. So that is 1 into equal to 4. We can see that, but we have to prove by delta epsilon. So for that, so first we take f of x comma y minus l, that is 2x plus y minus 4. This is x comma y and this is l. So first of all, let epsilon greater than 0 be given. Now find this, and from this we get 2 into x minus 1 and plus y minus 2. Then we will get this 2x minus y, 2x plus y minus 4. So it can be written as less or equal to 2x minus 1 and plus y minus 2. So if we choose this definition that f of x y minus l less than epsilon whenever 0 less than x minus x0 less than delta and 0 less than y minus y0 less than delta. So for our case, x0 and y0 are given 1 and 2. So we get 0 less than x minus 1 less than delta, 0 less than y minus y0, that is 2 less than delta. Then we put here 2 delta plus delta equal to 3 delta. So if we choose delta equal to epsilon by 2, 3 into epsilon by 3, then we get this. So we choose, that is, if we choose delta less or equal to epsilon by 3, then we get 2x plus y minus 4 less than epsilon whenever 0 less than x minus 1 less than delta and 0 less than y minus 2 less than delta. So then we said the limit of this function 2x plus y goes to 4 and x comma y goes to 1 comma 2. So let us take another example, and we will take circular disk in this case. Let us take this example f of xy equal to xy divided by root over x square plus y square. This is xy, and we have to find the limit as x comma y tends to 0 comma 0 f of xy equal to 0. So we have to prove that f of x comma y minus 0 less than epsilon whenever 0 less than root over x minus x0 whole square, that is x minus 0 whole square, that is x square, and this will be y square, this less than delta. So here first let epsilon greater than 0 be given. Now we have to find delta. So first we find f of xy minus 0 mod of f of xy minus 0, that is xy divided by x root over x square plus y square minus 0. So this becomes root over xy, sorry, modulus xy divided by root over x square plus y square. So this will be less or equal to, and we we know x minus y whole square always get up in 0. Then we get x square plus y square minus 2xy greater equal to 0. That is x square plus y square greater equal to 2xy. And from this we get xy less than equal to x square by x square plus y square by 2. So if we put here, we get this is less than equal to x square plus y square divided by 2 into root over x square plus y square, and this is nothing but root over x square plus y square divided by 2. And from this we now choose root over x square plus y square less than delta. So this becomes delta by 2. So now if we choose delta by 2 less or equal to epsilon, that is delta less or equal to 2 epsilon, then we get f of xy minus 0 less than epsilon whenever this inequality holds. So from this we can say that limit of this function goes to 0 and xy tends to 0. Thank you very much. If you like it, please subscribe channel to get update for future lecture. So thank you very much.